Yes, good morning, students. Am I audible? Yes, Mukund, am I audible?
Yes, ma'am.
Okay. My screen is visible. Very few students have joined. Is my screen is visible? Okay, so look into the syllabus. Today, what I was supposed to tell you, these are my part which I have written. What do you mean by absolute loader, which is also called as a bootstrap loader, and it is also called as why bootstrap, because there is no linking and there is no relocation. And your next syllabus is of relocating loaders. In loader, in general loaders, we have seen what are the functions of a loader. In general loaders being just loading them into the memory. That format also I have shown you in the last class, in the last webinars. I have shown once again. I will just tell you how I have shown, using which example I have taken memory cell example, and I have just shown you the example by showing the memory cells. This was the example which I have shown how the loading goes into the memory for the object code, and this is what your object file. And apart from that also, I have also shared you in the last class the relocating loaders, and today as I told you that direct linking loader, dynamic loading. Actually, direct linking loader and dynamic loading are one and the same, but here in dynamic loading, I must say it is all without again relocation, without relocation, without linking, and without loading. Sorry, without linking. So this, for this purpose, it is called as the dynamic loading. So today's class will be on, and what is the design of direct linking loading. It is same as of this. Direct linking loading design. How optimized code we will get during the time of linking and loading directly to the memory. So it is also design of direct linking loading is same as of the direct linking loading. So today's class will be on the direct linking loader. Now, what is direct linking loader? Direct linking loader, as I said, it takes the real relocation, and it is also it will also take again the linking and then go for loading. We know that what happens in relocation, the translators gives some sort of memory allocations to the program given, and that will be changed again, and after changes, after changes. Why change will be there? Because there will be some subroutines in the program. Due to that, it reallocates, and after that, linking happens, and linking also gives its own address of the linking. And some linkers will allow the programmer to be linked manually, then then generate an executable, then make it ready for loading into the memory, because on linking we get an executable file, and that executable file has to be loaded into the memory. So here, how the direct linking happens, as there will be many subroutines in the program. Somebody has logged in. Yes, am I audible? Is my screen is visible? So I was showing you the syllabus, so that you can see this syllabus. After this, which will be the last class of today's, I'll be making these topics, because this joining linking bytes are allowed dynamic pairing and then loading. So that's what it is called as dynamic loading. So here we shall first conclude how the direct linking happens. The direct linking happens here. Once again, I would like to recall you what are the functions of the loaders. What are the functions of the loaders? The functions of the loaders are allocation. Once again, I would like to display here. The functions of the loaders are allocations, linking, and loading. So allocations makes the space memory space where the object program would be loaded for execution, executions. You know very well that linking, it links many more object files of the subroutines of a program, and also the some library files and some other files which are, and some other necessary informations which are needed to allow the communication between them, and then go for linking and then loading. You know very well that what is loading. Loading brings the executable file or the object program into the memory for executions. So what we have seen, what are the functions of the loader, mainly that you should always keep in mind. What is the functions of the loaders? It allocates, linking, and then loading. What is a loader means? Bringing the object program into the memory is nothing but the loading. And why we have to bring the object program into the memory? We have to bring the object program into the memory for execution purpose. So during these circumstances, what is the best method for loading into the memory? We have seen different types of loaders. I have told you about bootstrap loader, which is also called as absolute loader. And during absolute loader, I have also told you about the I have also told you about how the absolute loading happens. This is how the loading happens. This is how the memory cell look like, and each and every object code will be set to the memory cell of the given address location, So this is what the address location given, and with its length also will be given. As you know, how is the object program? It is in the form of the three records, that is header, text, and the end record. So you should keep in this mind that how does it loads into the memory. So in direct loading, what is again direct loading? Direct linking and loading. I must say direct linking loader. What type of loader we are seeing now today? Direct linking loader. We are seeing today direct linking loader. So direct linking loader, it has to link the object file, and also it has to link some library files, and then go for loading into the memory, that means here again you should think in mind that it happens with three phases. That is, reallocation also happens because we are loading directly into the memory. It happens here. Relocations also and linking also happens, and then loading. That's what here overview I have written in the syllabus, that direct linking takes the relocations and linking, then go for loading. Relocations, linking, and then here in absolute loader we does not need any relocations, anything. Directly take the program and go for loading into the memory, and then go for loading into the memory. Which program directly take? The program which is generated by the assembler. That assembler program is of the object module program, and that object module program directly fits into the memory. So directly fitting into the memory, those lot of overheads, lot of problems will be there. So those all are solved by direct linking loaders, and also it is solved by relocatable loaders. But in relocatable loaders, one drawback is that it will not take the multiple subroutines or the multiple sub procedures, procedures into the memory allocation. It goes with one by one. So that is the drawback. So where what happens in direct linking loader? In direct linking loader, it allows for multiple procedures and multiple data segments into the memory. Here again, the programmer also is very free to reference the data or the instructions that are contained in another data segments. And also here for the programmer, it also provides some inter segments of the subroutines, and communication happens between some multiple procedures, and accessing ability will be there. That's what direct linking. By direct linking loader, one advantage is that many multiple segments. As I was telling the previous class, how does it creates the multiple segments also? I have just shown you one example also, by making as a virtual board also, during the period of this was the example. This was the example where here A it is, B it is, and C it is. uh, this is what the segment it builds. Memory segment, one memory segment it builds for the program, but it builds according to the address locations what it is being given. Assume that suppose it is 0 to 7, sorry, 0 to 57. So the next segment of the program, or the next subroutine of the program starts at 58, whatever is the length specification of this subroutine of the program of, I mean 14, some 58 to 40, plus 14. So till there, and again the next segment of the program for the C. So this is how this memory segment for the program given, of the subroutines of the three. Now here what does it happens during the direct linking loading? But here it is only a reallocatable example which I have told you. How does it makes the reallocatable into the memory? Sorry, reallocatable address in the memory. How does means whatever is the first allocate translated address by the translators, that will be changed in during the period of loading into the memory. That is called as the relocating loaders. Now here what we need to understand, do not look into this. Hello, yes, good morning. You are not aware. I was teaching, maybe you are late teaching that side. I mean, Tanmay, why don't you join? Okay, okay. I have joined you. Hello, you can see. Now, what happens here in the okay, okay. Now this is what the memory allocatable segment. This is what the segment, how the program segment look like. The program segment look like in this way. Again, somebody has logged in. Today, very few students are there. Yes, is there again somebody else to attend into the class? Very few students. Why today? Okay, I was been telling you about how was this the how was this, I mean, where you can observe the memory segment. In direct linking loader, what does it happens? As I'm taking this topic today, direct linking loader. In direct linking loader, as I said, it allows for multiple. It allows for multiple. It allows for multiple procedures and multiple data segments. Now this becomes as the multiple data segments. How many multiple data segments we have? Three segments we have. So the programmer is very free to access any of the segments. Okay, the programmer is free to access any of the segments, or also the programmer is very free to refer any of the instructions that contained in any other segment. So this is what the advantage by having the direct linking loader. By having the direct linking loader. So the direct linking, I mean, with this we know that the direct linking loader provides the inter-segment referencing and also the accessing ability. Now let us look into that. What are the requirements? How is the format of the direct linking loaders? Here mainly we need to understand in direct linking loader. It gives us the information such as length of the object code, segments, length of the object codes, and all. Somebody has logged in again. Very few students are joining. As I said, today will be the last class. Onkar, are you there?
जी मैडम सुन पा रहे हो।
क्यों आप देर से आए? हेलो,
नहीं, लगभग मैं 10:25 से कोशिश कर रहा हूँ, सबमिट कर दिया।
शायद मैं ये पढ़ा रही थी इसलिए देखा नहीं। ओके, क्या है मालूम ना? डायरेक्ट लिंकिंग लोडर reallocation linking happens, go for loading, reallocation and linking happens, and then go for linking loader. One advantage is that it allows for multiple data segments. Now multiple data segments, or I must say, instead of later I must say multiple data segments, I must say now it allows for multiple procedures or multiple subroutines. It allows multiple subroutines at a time. That's what is called as the direct linking loader. And here reallocating also happens, then go for loading. Anyhow, after reallocating, the linker will come and do the linking, whatever is the necessary communication, necessary information fix, and go for linking, and then go for loading, because it makes ready for executable file and go for loading. Then what does it happen in dynamic loader? Without relocation and linking, the without relocation and linking, the dynamic loading happens. Why we call it a dynamic loading? That I will later when I'm teaching this topic, dynamic loading. Whatever the drawbacks we find in the direct linking loader, that will be covered in the dynamic loading. Now, so far in absolute loaders, as we have seen, absolute loaders, which are nothing but the bootstrap loaders, means making the program, just bringing the object program into the memory for executable, that is called as the absolute loader. And in absolute loader also I have told you that this was the part. And in absolute loader also I have told you that how the directly brings the object program into the memory cell at a required specifications, whatever the memory specifications are allowed for each and every object code which are given in the somebody again. Very lately all of you are joining, all were telling this as बहुत सर पे बैठ गए. Is that you people सर पे बैठ गए because of me only? I think you people are cheating me because of my new entry as a CC. मुकुंद, बहुत से बच्चे तब 42 थे, अभी 32 हो गए. 10 people they have left. 10 people have left. 10 students have left. I was present. फिर मुझे टेक्स्ट भी करते, बहुत डरनेस है आप बच्चों में. मैं थी मैडम, वो नहीं था, ये नहीं था. पहले लेक्चर तो सुनते भी नहीं, फिर लास्ट में आके मैं थी बोलकर बोलते, और अटेंडेंस इस तरह से आप ले लेते. सुन रहे सभी लोग? नहीं सुन रहे शायद. ओके. Direct, what are the, now let me tell you how the direct linking happens. The direct linking, here it is very wrong, I must say as direct linking. Direct linking loader and dynamic loader, two topics which I am covering. Direct linking loader requires the length of the segment. Now the segment means what I have told you, that these are the subroutine. Here the segment A, segment B, segment C, which happens in the memory, which reallocates in the memory. So here the segment is very important. Now say for example the segment A is of 57 and the segment B is of 14K and the segment linking loading, what are the informations necessary information? There are some of the, there are symbols which are not defined in the segments, but they are referred, but reference is made to them. So for that purpose, during this period, they are stored in the use table. So we require a length of segment, we require list of symbols, and we also require who are the addresses, the content which are loaded in the segment. Constant means without the reallocatable addresses. So those are the things, informations. What are the informations for direct linking loading? We require the length of the segment. Also, we require the informations about the list of the symbols and the information which is loaded in the use table. In the use table, which is loaded, which is stored in the use table, the list of symbols which are not used in during the reference period of the data segment. So those symbols are stored in the use table. So these three data are required. These three informations are required for the direct. Okay, ask them to join. Radhika, are you there, Radhika? Radhika, are you there? Radhika. Hello, Radhika, ask them to join. Shruti has joined. Radhika, why are you not speaking? Onkar? Onkar, are you there? Onkar, am I audible? Mukund? Mukund? Mukund, am I audible? Giteshwari? Giteshwari? अभी अभी आप ज्वाइन हो गए ना? Am I audible? Okay, people are not responding. So what are these other things which are required for direct linking loading? And how is the data structure of the, see, people are disturbing the class. And how the data structure, now as I was saying that assembler, now here assembler, what these things are required, in the sense these things are provided by the assemblers. Now those which are provided by the assemblers, as I was saying that it is divided in this way. The assemblers which provide external symbols, I was saying symbols are required. How many symbols are there? Symbol list are required, and also the data segment is required, and also the use table is required. Now how these are, as these are required, and how they are nothing but these are the informations which are provided, or these are the records, or these are the cards, we may say cards. These are records or the cards which are provided by the assemblers. Now what information the assembler is providing? The assembler is for direct linking loading, external symbol directory. External symbol directory, this external symbol directory has the record of all the symbols that are defined in the program. So that, and that can be, why it is called as external symbol directory? Because it can be referred into the any of the segments or any of the subroutine of the program, wherever they are wherever they are defined. Now text cards are nothing but the text records. Text cards are nothing but the text records, and these text records control the actual object code which are translated versions, because different assemblers 8086, 8087, 8035, so based on the different assemblers you will be getting different object code. So it keeps the text record of the different portions of the assemblers. And it also, assembler also gives you the information, so what is relocations, and what which subroutine is relocation, which and their linkage directories, it also gives you the information about the relocation and linkage of the program, and also whose contents, whose contents, in the sense which are dependent or on the addresses at which the program will be placed. Means it gives you the second address also, which is called as relocation address also. Like say for example, which we have studied in relocation loader, the first address was 500 and the second address is 900. The first address was 500 and the second address is 900. This relocation address will be generated. And the next thing is end card, and this end card is nothing at all. That record indicates the end of the object file and also specifies the start address for the execution. Whenever you see any end record, even in this also I have told you, end record during the time of the loading, this is a simple concept of loading. Actually loading goes with linking, loading goes with relocation, loading goes with directly. So the loading which goes with linking and the loading which goes with relocation and linking is called as direct linking. And one more thing you should understand here, in this direct linking loading, it takes multiple subroutines or multiple procedures or multiple data segments. As I said here, ABC is the multiple data segment here in this memory. Okay, here in this memory. So in this memory allocated space, so that will happen directly, and they will have mutual communication. Each segment here, they will have mutual communication. That's what it is said as inter-segment or communication, whatever the data necessary which are referred to this A or B or C, they are internally they are referenced for any of the data. So that is what it allows the multiple data segment, and it allows the intercommunication of the segments. What is that? Is what it is called as direct linking loading. Now let us look into the example. Now here is a program. See here, already it is given with the reallocable address. This is already given with the reallocable address, and this PGI is nothing but the name of this program. And here AB are nothing but the entry which are made as which are called as the global, which are called as global variables. AB which are called as global, and this extern is a variable which we have PG2 and C. This PG2 is again another subroutine, maybe it can be a subroutine also, or it can be some other variable, or it can be some other function name, I mean subroutine name, or it can be some symbol. It can be some symbol that can be utilized in this program. Also, it can be utilized in some other PG1 program or PG subroutine program. These two. So these two are the variables which are used in some. On the whole, these are nothing but external reference variable. These are external reference variable, and here the line which it is indicating, it is nothing but some code. But here, after some code, assume that for AB it is allocated with the with the data storage constant value, that is A and B of the same data storage constant value, they are declared. So the end of this program, and they are at the because they are treated to be as the for. Now one more thing you should understand here, where I said here I mean where these are also called as public definitions, these are also global definitions. These global definitions are now they are used in this program. When they want to be used in the program, of course they are required to be declared. So that's what they are declared here at the address called as 20 and 24, and further they are reallocated at the address called as 40 and 44 with 48, some manipulation of that, with some manipulation of that A. It is being added 20, it is being subtracted by 25, and C is being subtracted by some value called as 5. So, and they are again reallocated at the address called as 40, 44, and 48. And the end of this record also tells you that this is the end, or it also gives you the length of this program. 52 is the length of this program. So 0 to 52, one big subprogram, sorry, one big program name called as PG1. It is the length of this program is 52. So this is what the reallocatable address, and this reallocatable address, that which is generated by translate, and this is the address which is going to be during the period of linking. During the period of linking, this is the reallocatable address generated by the linker, and after this again the for this also we call it as linking address. For this we call it as linking. And as I said, as per this formula of the direct linking address, the second, this is what the Excel directory and text card and the reallocatable linking directory and end card. This is what the example which I want to indicate for this given database. Now, first one is what? External symbol directory. Now, external symbol directory, it consists of again the three types of the definitions, that is segment definition, local definition, and external references. Now, the segment definitions, who are the segment definition? Now, as I said, the name of the program is PG1. So this itself is one segment. This itself is one segment. PG1 is called as. Now you observe who are the PG2 and C are not used in this segment. Onkar, are you understanding? Onkar, Mukund, Sonia, Ahalya, Mukul Kapale, you are there in the class or not? Onkar, yes, are you understanding? Shruti, Pranesh, Sonia, Pranali, Aparna, Anisha, Dipti, Gauri, Geeteshwari, understanding Geeteshwari, Mayuri, nobody is answering.
Yes, ma'am, understood.
Why nobody is answering? Radhika, Sonali, Sonia only should have texting. Here not telling any answer. Pranali, Dipti, Akanksha, are you there? Pratika, simply I am shouting on one way. Kajal, Vivita, Rasika, Kshitija, Sonia. Okay, Kajal has responded. Good. Are you understanding, Kajal? Yes. Yes, understanding, Kajal. Aparna. Okay, I will tell on my own way. So here this is the segment program. In this program segment, this is very, very important. Listen here. In this program segment, now in this program segment, what is being used? Only which variables are used? Assume that first of all the symbol PG1 and AB are used in this segment. So which are not used from this segment are PG2 and C. So they will be stored in the use table. These two variables will be stored in the use table. Now look into the first record, first card. First card is what? First card is external symbol directory. The first card is what? External symbol directory. And this first card, external symbol directory, contains again three types of definitions. It will pick only the informations of the segment definition and local definition and external references. Who were the external references? PG2 and C were the external references. PG2 and C were the external references. These were the external references. And PG1, now see here, PG1 and AB were the PG1 is called as the segment definition, which is nothing but the name of the segment. What is the name of this program? The name of this program or the segment is PG1. So these are the informations which are provided by the assemblers. So these assembler informations it will take. These are the informations which are provided by the assemblers. And what are those identifications? Those identifications are nothing but first PG1 is the first entry into the symbol table. Assume that, and A is also first entry into the symbol table. B is also first entry into the symbol table, and PG2 is a second entry into the symbol table, and C is also the third entry into the symbol table total. So here, why? Because I must say here, first entry, but as per the symbol table, it becomes as the third identification. Now here reallocation. Now just look into what are their reallocation of the PG. PG1 is 0. PG1 is 0 and AB are allocated here. These are the forward references are allocated at 20 and 24, reallocated at 20 and 24. And sorry, these are allocated at 20 and 24 because of forward reference, and these are again reallocated at 40, 44 and 48. 40, 44 and 48. Look into that. So these are the allocated 20 and 24. AB 20 and 24. See here 20 and 24, and this is 0 is for PG1. Why we want to pick such addresses only? Why? Because these are related with the these are related with the variables or the symbols. These are related with the symbols. Why these are kept as dash dash? Because those are not used in this segment. These are not used. Pg2 and C are not. See here. Pg2 and C, how they are not used. Look into this figure or the program. Pg2 and C are see here. Pg2, is there anywhere used in the program? In the segment? No, they are not used in the segment Pg2. So that's what. Now, again, what is the length of the program is 52. As I said, the end indicates the end record also is at 52, and this indicates the end of the program also, and also we can guess that it is the length of the program. The length of the program is 52. Next record is what? As per this database, which is provided by the assembler, it is a text card. This text card controls the actual object code translated versions. Actual object code. This text card, and how is its format? It includes the different operations performed on it, and also it gives the flag is very important in this table. Now this reallocating and linkage directory, reallocating this relocating and linkage directory is at such a table which is having the ESD ID. Now ESD ID is nothing but external symbol here, external symbol directory. Now external symbol directory is the first one. What are the symbols which are used in the external symbol directory? A, B are the symbols which are used in the external symbol directory, which are used in the A, B, C, which are used in the external symbol directory. And what is their IDs? Their IDs are 1, 1 and 3 here as per given in this 1, 1. See here 1, 1 and 3 as per the IDs given in those symbol. And what is the flag generated? Here the flags are plus, and here it is minus, and here it is minus. Now those flags in the sense, maybe in their addressing modes, those flags are raised, those flags are used. Now are a reallocatable address for A, B and C. Now look into this A, B and C, reallocatable address. Now reallocatable address, see here 40, 44 and 48. In this program even C is also used. In this program even C is also used, and it is reallocated at C is reallocated at 48, A is reallocated at 40, B is reallocated at 44. So the same information is given in the table also. These informations are provided by the assemblers. Reallocating and linking address. See here, reallocating and linking address for whom? Sorry, linking for address for whom? Reallocating and linking address only for those variables which are used in the segments, which are used in the segment. A, B, C are used in the segments. A, B, C are the symbols. And what is their reallocatable values? Their reallocatable addresses, see here. First allocated address is 20 and 24. Again reallocatable address is 40, 44 and 48. So this is what the reallocatable address. So 40, 44 and 48. Next database is what? After a text card, in text card, what I have shown you in text card? Sorry, in text card, text cards are nothing but those are the informations which are generated by the object code. Those are the informations which are generated by the object code. So that there is no such table in that text card. Relocation and linkage directory has got the table. This is what the table. The type of the table is with the flag. It has the information about the symbols and the flag. In direct linking, only it is the information related with the symbols, only which are used in the segments or which are not used in the segments. And how is their reallocatable address? So this is that. And next is, what is the last record or the last card? The last card is end card. The end card indicates the end of the object file and also specifies the start address for the execution. The start address for the execution, how does it specifies? I must take this pic. what is end card is which specifies the end of the program, that is at 52. 52 is end of the is end of, and what is its length? Length is 52. And where it is it also gives you the address where it has to execute in the memory, so that both the addresses are added. So the total address generated by the PLA, and also the length, so this is what the this is what somebody has joined or left. Okay. Understanding, I have told you now about direct linking. I have told you about direct link. So these all since all the addresses cannot be resolved in the starting, so some addresses will be resolved during the pass 1 and some addresses will be resolved during the pass 2. So in pass 1 it performs the defining of the segments and with the local segments here. In pass 1 with the defining of the segments and the local definitions like ABC. These are the local definitions, and pass to it works with the text and RLD. RLD is relocatable linkage directory. So end specifies the end of the program, and plus it also gives you the length of the program. Both together it will be added, and whatever the resultant is produced, that address will be given for the loading. And just this is what all about the direct linking loading. Yes, understood, Radhika, Giteshwari, Onkar is there? So how many records we have? How many cards we have? It makes use of the 4 cards. That is external symbol directory, text cards, relocatable linkage directory, and end card. These are required. Onkar, are you there? Onkar?
जी सुन पा रहे हैं हम आपको.
ओके ओके. नहीं, जवाब ही नहीं दे रहे ना आज कोई भी.
नहीं, आपकी आवाज मुझे काफी रुक रुक के आ रही है.
अच्छा अच्छा, शायद आपका ही रेंज होगा. मेरे तो एक बार भी डिस्कनेक्ट नहीं हुआ.
शायद हो सकता है मेरा, ये मौसम में खराबी इसलिए हो सकता है.
ओके. चल दे. गीतेश्वरी, ऐश्वर्या, अनीशा, उनकर आप म्यूट कीजिए. शीतल, सिद्धि, सोनाली, अंडरस्टैंड हो गया? अब दूसरे टॉपिक देखेंगे. We shall see the next topic, that is, so this is what all about the direct linking loading. Direct linking loading में क्या होता है? लिंक करता है सब रूटीन्स, और सब रूटीन्स एक साथ ही मेमोरी में जाते हैं, और जो भी सिंबल्स वो सेगमेंट्स में वो सब रूटीन में यूज होता है, वो सेगमेंट का इंफॉर्मेशन असेंबलर प्रोवाइड करता है. विद दिस डायरेक्टली लोड्स इनटू द मेमोरी. और जो सिंबल्स यूज नहीं होता है वो सिंबल्स यूज टेबल में रखता है, और जब भी आवश्यकता पड़ने पर वो सिंबल्स को यूज करके मीन्स इंटर सब रूटीन्स, जब भी आवश्यकता पड़ने पर वो दे कम्युनिकेट एंड दे link and go for loading into the memory. So but here you should remember the direct linking loading takes the 4 records. What are those 4 records? External symbol directory, text directory, relocation and linkage directory, and the end card. These are the 4 records or 4 cards. Okay. Now next, and I have shown you with the example also. Next is dynamic loading. Now here you should need to understand what is the dynamic loading. As I said, in dynamic loading, now here during the period of direct linking loading, what I said, now just look into the syllabus here, brief overview I have given. इन डायरेक्ट लिंकिंग लोडिंग रीलोकेशन और लिंकिंग होता है। रीलोकेशन कैसे हुआ आप देखे हैं, ए बी सी को रीलोकेट किया, ए बी सी को कैसे रीलोकेट किया, जस्ट सी हियर, ए बी सी को कैसे रीलोकेट किया, ए को 40 पे जाके रीलोकेट किया, 44 पे और 48 8 पे रीलोकेट किया। पहले सी कहाँ पे था, 8 पे था, लेकिन ये पकड़ते नहीं इसको, उसको मीन्स इफ दे हैव बीन डिक्लेयर्ड, if they have been declared, then it would be called as the symbol. But right now in this program again it is used, so therefore here it is again, it is found at directly it is found with the relocatable address with direct subtraction. So here these part are called as relocatable address, and this gives for linking. These are the addresses which are generated by the assemblers. Okay. And one more thing I told you should understand very carefully here, the drawback which is found in direct linking loader, it is resolved in dynamic loading. And one more thing I have told you, this is what relocatable, and how does it does linking, again कई format रहता है, linking directory format. So how was the linking directory format? In linking directly, see here this database relocation and linkage directory format, it contains the addresses at which the program is placed. So we have seen all the it contains the address at which the program is placed, means at 0th address the program is placed. With this linkage address plus the length of the, so it goes for loading. You should guess here where the program which is loaded. The program is loaded at 52. The program is loaded at the address called as 52. So these were the address, these were program relocation and linking, and with the help of whatever the flags information we have. So with the help of this, again end में क्या होता है, end में program relocatable address plus the length. So plus the length, that is 0 plus 52. वो जाके लोड होता है मेमोरी में इस तरह से. But you should think in mind that what I said here in direct linking loading, uh, in direct linking loading, it takes multiple, or it takes the many more segments. It takes the many more segments, and the segments, these many more segments or the multiple procedures goes into the memory for execution. Now here in dynamic, what does it happens? In dynamic, these multiple procedures, it allows for multiple procedures into the memory for execution, and it also allows for the programmer to have the communication among them if any necessary information is required to execute. So it will give you that information also. So that is what the direct linking loading. Now here in dynamic loading, before going to the dynamic loading, you should understand here you should understand here, as I said, it will take all the procedures into the memory. So when it is taking all the procedures, sub procedures or the sub programs, I say, into the memory for execution, A, B, C, into the memory for execution means whatever may be the length of the program of the subroutines, it will not take that in mind. It will take all the procedures into the memory. But by this, what does it happens? Memory get overloaded. Though any of the segments is required for execution or not, it is taking all the segments, all the subroutines into the memory. Unnecessarily, it is taking everybody into the memory. So this drawback is solved by dynamic. Though the full program is loaded into the memory, now in dynamic loading, what does it happens? It calls only that subroutine which is called by the program. Rest segments will not be loaded into the memory. Rest of the segments, it will not be loaded into the memory. So what it will take? It will take only that segment or that procedure which is required at that time during the execution. During the execution. So that is what it is called as. It is called as the dynamic loading. What is dynamic loading? It's a mechanism by which the computer can at a runtime can load the library and other binary into the memory and retrieves the addresses of such a functions and variables. Retrieves the addresses of such a functions and such a variables which are contained in that library and executes only those functions. And executes only those functions or those variables and unload and it unloads what? It unloads the unnecessary informations, unloads the library from memory. Okay, so that is what the dynamic dynamic loading. The dynamic loading, as it takes the main program for main program in the sense the object program for executions. For XCR, I have written very clearly. Sometimes the full program is loaded into the memory, but sometimes a certain part of the routines program is loaded in the memory only when it's called by the program. And this mechanism is called as the dynamic loading. Now here you can see picture which I have, but let us compare that dynamic loading with the static loading. In static loading, what does it happen? It holds such a loads. It holds such loads and forces them only during the period of execution. It holds such a loads and applies them only during the period of execution. Okay, so that is called as the static type. Now here during the dynamic loading, see here only this subroutine is called. Only this subroutine is called for execution in the main memory. Only this subroutine is called for execution in the main. Though this program is ready for execution, but in this which subroutine it is called? It is called by memory. It is called by memory only this subroutine. It is called by memory and it should be ready to execute dynamically. See, it should be ready to execute dynamically. That is called as. So that's what here in the syllabus I have written here. As dynamic loading is without relocation and without linking. As here it is with relocation and linking, so here dynamic loading is without relocation. I must say here such multiple procedures are loaded only when necessary. Are loaded only when unnecessary. Multiple procedures or multiple segments. So that is what it is called as the dynamic loading. Yes, understanding? Hello? Giteshwari? Are you there? This slide is so, contrast. Yes, Giteshwari? Prashant? Mayuri? Rutvij? Now let us see the next part, which is nothing but let us see the next part. Now here if you want to see into the dynamic loading, dynamic linking loader, here I have written some of the points. Dynamic in general, the dynamic linking loader is a general relocatable loader and allow the programmer multiple procedure segments and multiple data segments, giving the programmer complete freedom for referencing. Whenever as and when programmer requires of the segment, that time he can go back and he can come back whatever information which are required in the subroutines. In any of the subroutines he can take. It is as what I have explained, the same example. Now design of direct linking loader. Now these two topics are over. So design of, now the next one is also finished. Now the last part which is left out is design of direct linking loader. Now design of direct linking loader, here you should imagine the same story in the sense which I have told as direct linking loader. Direct linking loader takes the information which is given by the assembler. What is the information which is given by the assembler? What is the information which is given by the assembler? But it goes with the pass 1 and pass 2. Okay, programmable load addresses and the uh, program load address count, it counts as I stopped there with that only. Now as I have told you, the records, RLD records, this is another example which I want to show for the pass 1 and pass 2. You need to understand here, during the pass 1, what does it happen? During the pass 1, same what I have explained here in direct linking loading. In direct linking loading, as this example have been taken, and what are the database, external symbol directory, text cards, relocation directory, and end record. What the external symbol was telling? The external symbol was telling us it is having some three type of definitions. That is the segment definition, local definition, and external definitions. And what are their identifications? Based on their identifications, based on the type, and based on the relocatable address, and based on its length, it makes such information, and this information is required for ESD. ESD, which is nothing but external symbol. External symbol directly. This directory is produced by the assembler for a program. And next is what? The text card. The text card holds the records of the object program. So I did not explain much more on that. It holds the record of the object program. Now next, on the third card, what is the third card or the third record? Relocation and link directory. The relocation and the linkage directory, how was the format? This was the format. External symbol directory ID. Who was the external symbol? Various were the external symbols, and what were their IDs, and the flag, information of the flag, and also the reallocatable address. So that was the information which is produced by the relocatable link directory. And next information, what it was? Next card. What is next? And as I said, end card gives you the end address plus the PLA, program load address. So the program load address is that 52 plus start address. Now here, what does it specify? It indicates end of the object file and also specifies the start address for the execution. It has to start. Where it has, I have shown you here at the another slide. End of the program means it gives you where this when you can call it as direct linking loading. This end record only. It holds the address of the program load address plus the end as the length. Length here is 50. Program load address, where was the program load address? Suppose the program load address is 500. Suppose the program load address is at 500. If it is 500, so 552 will be the unallocated memory address, which at that address, at that address 552 address, the loading takes place. The loading takes place. So that is what here which I need to express. But here in this topic, design linking loader of the optimized code. Here certain codes will be optimized in the segment 1, segment 2, and segment 3, as I have taken here in the example. This example, program A, program B, program A in the sense subprogram A, subprogram B, program C. So these programs will have the optimized code. Will have on the whole, this optimization will happen before the loading. When does optimization happen? During the compile time. Compiler will do the optimization of the code. What the compiler generates? The compiler generates the optimized code. How does it generate the optimized code? If suppose any instruction is used for multiple times, and if suppose any variable is not used in the program, in the same way here also, if suppose any variable is not at all used by the subroutine, so that subroutine, that variable will be called as the code. So in this way, it will pick the optimized code. So during this time, it requires some pass 1 and pass 2. So in pass 1, what does it happen? What are the databases it creates in pass 1? The object, it keeps the object program and input program, and it will have the initial program load address supplied by the programmer, operating system which specifies for the first here for the segment, and it is used to keep track of the segment assigned location, and also it will keep the global external symbol. So this is how the pass 1 it does. And in pass 2, what does it happens? In pass 2 also, in pass 2, it in pass 2, a copy of the object program will act as the input, and this innate keeps the initial program address, and also it keeps the count, and also it keeps the external reference symbol like this. External reference, who was the external reference symbol? The external reference symbol, this table, external reference table. This external reference table. It's the record of the external reference table, and the local external symbol array also, which is used to establish the correspondence between any of the external any of the external symbol directory IDs. Who are the IDs? External symbol directory IDs. In the second text structure, sorry, in the linkage we have here, relocating package this ID keeps. Okay, this all takes in the past. This all address information takes in the past, which are used in the ESD and records correspondingly, as you know that. So this it creates the pass 1, and sorry, with this it generates the pass 2. So with this generation of in pass 1, what the information it is taking? In pass 1, it is taking information about it is taking, see here, you should be the design of the, what I am explaining now, the design of the, here in pass 1, what information it is keeping? The information initial load address. Suppose initial load address is 0. Initial load address is 0. It's count to 2. Okay, at 50. And global external symbol table. What is the global external? A, B, C. I have in my program what I have shown in this. What A, B, C. These A, B, C and PG2 are the external symbol references. Okay. Then next, what it needs? in pass to RLD. It keeps the record of RLD and also the local external symbol array. RLD and local external symbol array. Okay, these informations. And these records, as usual, the source reference, name, type, ID, relative ID, and length. This I have told in ESD card. Here, how is the ESD card? ESD symbol, ID, array. Instead of array, here I have here it is told as relative address. Array is nothing but relative address and also the length. And also so reference, type, and to understand length. So this is how format. source card reference. Here in source card reference, instead of source card, that column I have not taken. Source card reference is nothing but for the program, PG1. So what are the symbols? A, B, C are used, and type, what are this? Segment, local definition, segment definition, local definition, and they are the external references. And the relative addresses were 0, 20, and 24, which are relative addresses, which are also called as relocatable addresses. And the length was 50. This was the format. And what was the text card? Text card keeps the information about the source card reference address. Source card reference address, here it is 0. Source card reference address, here it is 0. And relative addresses of the object program and its content, full object model content it keeps. And RLD, relative linkage directory. In relative linkage directory, again source card reference, the ESD ID. Who were the ESD ID? A, B, C, and PG1 were the ESD. ESD means external symbol directory. What were their IDs? A was 1, B 1, and 3. What was their length and their flags? Okay, their flags are in store, and what are their relocatable or relative address? Relocatable or relative address were found at 40, 44, 48, like that of ABC. See here, relocatable address were found at 40, 44, and 48. If you see the program, 40, 44, and 48. These were the relocatable or relative addresses. Relocatable or relative. And finally, the one more is of global external symbol. Who was the global external symbol? G1 was the global external symbol. And what were those address? The global external symbol address was found to be at, if it is used in another program. And what if it is used by another subroutine, means what is its address assigned, and what is its address assigned would be the, like that. Now here in this external symbol was A and B and C external, and therefore the addresses were 40, 44. C was 48, like that. Local external symbols. The local external symbols, the previous address. The previous address of this A, B, C were locally to this segment. A, B were locally, and C is also locally to this program. But C is also locally to this program, but C also can be used by another external reference, another subroutine. So that C also becomes an external symbol at time if it is used by another program, another subprogram. In this are data and 24 are okay. This happens of transparent parts. Okay, so this completes the design of direct linking loader. Design of direct loader. I have told you I have completed all this. So this completes your syllabus. Yes, Omar, have you seen the reconnection. Mukund, Kajal, Akshata, Vivita, Rutuja, Pratik, Ahilya, Nehal, Vita, Kajal, Kshitija, Sonali, Saloni, Rasika, Vaishnavi, Nia, Nali. Oh, sir, somebody respond. No, with this I have completed all the Mukund. Am I audible? Yes, are you there? Sakshi, what evening? Am I audible? Mukund? Yes, Mukund. Don't post your attendances. When I ask you, just post. Aparna. So with this, the syllabus of your is finished. Mukund, have you understood? Rule number 1, two, 3.
Present, ma'am.
All one is present.
Have you understood? Have you understood? Shivani?
Yes, ma'am.
Right from the beginning. So the design of direct linking loader with the help of pass 1 and pass 2. In pass 1, it takes record of the only E and with the initial PLA. Initial PLA in the sense program load address. And in pass 2, it takes the record of the ESD and its ID. ESD and its ID. And it go for loading of the program. So I have shown you the all the formats, and with the help of the local external symbol and the global symbol. So I have shown you how is the format of the pass 1 and pass 2. In pass 1, initial PLA, and in pass 2, initial PLA plus ESD with the RLD also. ESD ID with RSD. Sorry, RLD. What is ESD ID? External symbol directory IDs. The IDs of A, B, and C were 1, 1, and 3. Like that. So, Shruti, have you understood?
Yes, ma'am.
Okay, with this, your syllabus is completed. From next class onwards, I'll do the revision, and still I have to take linker and loader. So actually, I thought of taking the test both together. Test in the sense the MCQ on linker and loader. And you may be very much aware that database record I have, which I have conducted the class test during the month of June or July, when I was very new to your SP subject to handle. After finishing the first chapter, I have conducted the 1 unit test. So all objected. So soon the unit test was conducted. So that record I have preserved like that only. So another unit test I may conduct. Let me conduct on linker and loader 1 MCQs. Okay. So tomorrow I will conduct 1 MCQ and test. So hope you hope and what rest of the time whatever is available, that will be used for the revision of your class. Yes, is that clear? Any doubt? And most of the students, one more thing here, whatever this CSA 18, which is posted by your classmate Onkar, CSA 18 is only for A division or B division also? CSA 18 at COEP. Mukund, are you there? Onkar? Shruti? Shivani? Roll number 2? Roll number 20? Roll number 20? Roll number 5?
Yes, ma'am. Yes, ma'am.
5. Roll number Tuja. CSA 18 is only for your division or B division also? Hello, Rutuja. I'm not taking attendance. I'm asking you. All are jamming now. All coming. Strength is 50. Hmm?
I
Hello,
think it's
Rutuja
only for division A, ma'am.
A. So I'm posting now one handwritten notes right from the compiler. Did you received compiler handwritten notes? I hope you have received. Only linker I have not posted the handwritten note. Did you handwritten answer? No. Sonia, Mayuri, Vishwajit, Prashant, have you received notes on compilers, handwritten compilers notes on SP group? Roll number 6. Why Rutuja you're not? Don't post. I'm not going to these post attendances. Yes, Saloni, Gauri Kulkarni. Are you there? Compiler handwritten notes are there too. Okay, this handwritten notes. Onkar, Onkar, Sakshi, पूजा 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 से 18 ये
Yes,
सिर्फ ए डिवीजन है क्या? बी डिवीजन आप
yes,
बात
ma'am. It's for
कीजिए. ये से 18. हाँ ठीक है, क्योंकि ये मेरा हैंड रिटन है ना, तो इफ आई पोस्ट सेक्शन टू योर नो, दैट्स व्हाट आई एम आस्किंग.
okay, ma'am.
ये CSA 18 जो भी आप मेल आईडी दिए वो ये सिर्फ ए सेक्शन के लिए है ना, ये डिवीजन के लिए?
हाँ मैडम, हाँ सही है.
हाँ ठीक है. अभी देखो मैं कंपाइलर्स के लिए पोस्ट कर रही हूँ नोट्स ऑन कंपाइलर्स. 4th यूनिट क्या है? कंपाइलर्स है. देखो 5th यूनिट क्या है? लिंकर्स है. 6th यूनिट लोडर है. ये कंपाइलर्स के हैं. देखो हैंड रिटन नोट्स. फिर मैं क्या करूंगी, और एक बार ये अभी लोड हो गया मेरा, शायद डेटा कम हुआ. और एक मैं क्या भेजूंगी लिंकर्स के लिए शायद. लिंकर्स का भी भेजूंगी. पूजा आप देख रहे हैं? पूजा, इज माय स्क्रीन इज विजिबल?
No, ma'am. Your screen is
अभी
visible.
वो स्क्रीन इज नॉट विजिबल.
Yeah, ma'am.
Now have you check your mail? Have you received notes on compilers? Notes on compilers. Is voted 18. things I say पूजा, हेलो पूजा।
मैम आपकी आवाज नहीं आ रही है, बहुत कट हो के आ रही है।
रोल नंबर 1,
Present.
2, 3. So with this, your syllabus is completed. Okay. Whatever the timing I will be getting, I will be doing the revision. 4,
For
5,
present.
6,
For present, ma'am.
Present. 6
okay,
present.
Ma'am, 5 is
7,
present.
okay, 8,
Present, ma'am.
9,
9 present, ma'am.
10,
Present, ma'am.
11, 12, 13, 14,
Present, ma'am.
Present 14.
Ma'am, 12.
16,
Ma'am, 15 present.
okay, 17,
Ma'am, 16 present.
18, 19,
19 present, ma'am.
okay, 20,
20 present, ma'am.
21,
Present, ma'am.
22,
22 present, ma'am.
23, 24,
Present.
25,
Present, ma'am.
26,
Present, ma'am. 26.
27, 27,
27 present, ma'am. 27
28,
present.
28 present, ma'am. 28.
29, 30,
Yes, ma'am.
31,
Present, ma'am.
32,
32 present, ma'am.
33,
Present, ma'am.
34,
Present, ma'am.
35,
35 present, ma'am.
30,
36 present,
36,
ma'am.
37,
Present, ma'am.
38, 39, 40,
40 present, ma'am.
41,
Present, ma'am.
42,
42 present, ma'am.
43, 44,
Yes, ma'am. 44.
45, 46, 47, 48,
Present, ma'am. 48.
49,
Present, ma'am.
50, 51,
Present,
52,
ma'am. 51 present.
53, 54,
54 present.
55,
55 present.
56,
56 present.
57, 58,
Present, ma'am.
59, 60, 61,
Present, ma'am.
62, 63,
Present, ma'am.
64,
Present, ma'am.
65,
Present.
66,
Present.
67,
Present.
68,
Present.
69,
Present.
70. See, your mail is reverting back. What the post which I have posted? Okay, see here. What the mail ID you have given CSA 18. Sorry, CSA 18. This mail ID it is reverting back. See, this group does not exist. It is telling. What to do? Hello? Here, CSA 18 COEP. Is this your group mail ID? Just now I have posted. I got a reversion back. Okay, with this your syllabus is completed, and if you have any doubt, you ask me. Tomorrow there will be a test on loader and linker. Sorry, linker and loader. With that, it completes all the tests, and one test I have conducted. All the totally 5 MCQs I have conducted, and one test I have conducted. And this will be tomorrow's will be MCQ on linker and loader. 2 MCQs will be conducted on linker and loader. So and rest of the remaining time I will conduct the revision. Thank you all. If you have any doubt, you can ask me now also, as and then whenever it is required also. and most of the students have told me give the notes on handwritten notes. So I'm trying to post. Due to the network it's reverting back or what, I don't know. Once again I'm trying. I have the handwritten notes for linker also I have done, so I will try to post.
Hello,
Now
ma'am.
see on linker the handwritten. Yes, tell.
Ma'am, 59 Mukund's mic is not working. He's present.
Okay. Should I have to repeat all the absentees? Handwritten notes on linker I'm sending. Just check it out. Okay, your absentees note down 2, 10, 12, 17, 23, 39, 44, 45, 46, 47, 53, 59. Now 59 is present. 60, 62. These are the absentees.
Hello, ma'am. Ma'am, 12 is present. Madam, 10 is present.
Then
Hello.
12 is also present.
Yes, ma'am. 10.
45.
Next. All are present with this. Some will join, some will not join. Then who is absent? 2 is absent or what? Okay, CSA 18 is only for your division, no? Prashant? See, again it is telling as mail is reverted back. Prashant, check, did you receive my mail or not? Prashant,
No, ma'am, we didn't receive any
you are
mail.
telling yes here, what I should. See here it is telling that this group does not exist. Whatever the mail ID you are giving, that group does not exist. Okay. Please verify. Someone send me a message through that group. Some hello message you send me, some mail. Hello? Pooja? Hello, Pooja.
Yes, ma'am.
Can you say mail me?
Okay, ma'am. Okay.
Hello, can you mail me? Mail me through your ID, I mean college ID for your group what it is given, so that I will forward the same to that only. See, it's reverting back. I hope now again the presentation is stopped now. But this is the second time whatever the fresh mail ID is given to me, I'm trying with that. It's reverting me back. Can you send me some mail? Okay, thank you all. If you have any doubt, you can ask me. Thank you all.